Hello everyone. In this project, we will be utilizing the different tools, concepts, and libraries that we have learned throughout this series to conduct some analysis of a particular dataset. Keeping in mind that this is a solution walkthrough, so I have created the different tasks and I've already written the code required to do the different steps. That's because it's going to take us a lot of time to write the code from scratch. Rather, what I will be doing is just to touch on certain aspects in the code that can be ambiguous and focus on some other aspects that are important to understand. All right, so we will be doing some data collection, data cleaning, and then data exploration, and then data analysis. Okay, starting with the data collection, I have basically collected the data, or rather downloaded it from a website called kaggle.com, which is basically a community of data scientists where you can find free data sets that you can download and experiment with in order to learn the different skills. And I will put down the links to the datasets we have utilized in this project so that you can maybe download them and experiment with them on your own. All right. So in terms of data collection, we have the data as CSV files downloaded to my computer, and I will be importing these datasets into data frames to go through the different steps here, including cleaning, exploration, and analysis. All right, so let's get started. The first thing we do, as always, is to import the required libraries or the libraries that we need in our project, right? In this case, we will be using pandas for the data analysis, exploration, and cleaning, and we will be using matplotlib to create some data visualizations, in addition to NumPy, which we might not need necessarily, all right? And it's always recommended to keep all the import statements in one cell at the beginning of your notebooks. Okay, next we move on to the part where we read the data sets or the data tables into two different data frames because we have two different tables. Okay, and for that we use the PD alias for the pandas library, and from there we use a function called read CSV. Read CSV basically takes the path to a CSV data and return or produce as output a data frame. In this case, we will store the data frame in a variable. All right. Now, before we get into the details of the data sets we have, uh, let's talk a little bit about the concept of the file path, which we introduced in the introduction to key computing concepts, if you remember. The file path is basically the series of the folders and subfolders that we must go through in order to reach a particular file. And it's always relative to the file that we are currently working on. So as you can see, right now we are inside a file called project.ipymb, right? So where do we need to go from project.ipymb to reach the car basic data.csv? All right, how can we know that? By taking a look at our file explorer. So here is our project folder. From there, we go to data, and from there, we reference the file that we want, right? So again, we are in project, we go to data, and then we go to the file we want. In case it was inside the extra folder, then we get inside the extra folder and then get to the file we want. So in this case, we went to data since it's at the same level at the file project slash to get inside another or to specify another subfolder or the file, and then we specify the name along with the extension of the file we want to read. Now, the data we want to read is CSV data, which stands for comma separated values. So, for example, the car basic data is stored as a CSV file. Now, in CSV, the rows of data are called data records. Inside each data record or row, we have different fields or values. And the first field or first row, sorry, or data record is the column names. All right. So in the first data record, as you can see, we have all the column names separated by commas, and thus the name comma separated values, right? So we have car ID, car name, door number, car body, etc., etc., etc. Now we go to a new line to indicate that we want to write down another row or data record of data, right? We go to a new line here and we write down our fields or values separated by a comma. So we have 1, comma, Alfa Romeo, comma, 2, comma, convertible to RWD, etc., etc. Now each row or field is basically a value under each column. So for the car ID, as you can see, we have 1 here, 2 here, 3 here. For the car name, we have Alfa Romeo here, Alfa Romeo here, Alfa Romeo here, Audi, Audi, etc., etc. All right, so 2 characters to focus on. The new line to indicate that we want to write a new row, and comma to indicate that we want to write a new field or value in the same row. All right. So the pandas library, specifically the read CSV function, automatically will get the data stored in this CSV data file and convert it into a data frame. Okay. Now there are some other extensions that pandas can read, or file types that pandas can read, like for example TSV, which is tab separated values. So rather than using commas, we use tabs alongside many other extensions or file types. All right. So the data we will be working on, or the data sets we'll be working on, are the car basic data dataset and the car engine data. So again, we use the read CSV and we store the data frames inside these two variables, df basic data and df engine data. Now let's go through the steps one by one and see how we can achieve them. So first, take a quick look at both data frames. All right, first thing, let's run the first cell to do the import. Second, let's read the data to both files. And then take a quick look. How can we take a quick look at a data frame using the head function or the tail function? All right, so we take this and call the head method, sorry, not function. Why? Because the data frame is a class that consists of methods and attributes. So head, and we read it. As you can see, here is the data frame of TF basic data. Now let's take a look at the different columns here. First, we have the car ID. All right. Second, we have the car name, the number of doors as door number, the type of the car body, whether it's convertible, hatchback, etc. The drive wheel, rear wheel drive, forward, four-wheel drive, etc. The engine location, front or back, the wheel base, length, car width, car height, car weight, and finally the price of the car. All right. So basically, the DF basic data contains some uh, uh, the specifications of multiple cars. Okay. Now let's take a look at the other data frame, which is the DF engine data using similarly the head method. As you can see here, we have data about the engine of the different cars. Right, so in the first data frame we have general characteristics or specifications. Here we have the engine characteristics. So for example, we have the engine type, the fuel type of the car, the number of cylinders, the size of the engine, fuel system, bore ratio, stroke compression ratio, horsepower, peak RPM, city MPG, and highway MPG. All right, and in this analysis, we won't necessarily need all of these columns to do our analysis, but they are there. And for now, we will work with whatever we need. Okay. All right, next, get the data type of the DF basic data frame columns. So the data frame consists of multiple columns, and each column contains values of a particular data type, right? How can we get the data types of the different columns? Using the dtypes attribute in the class data frame, right? We've talked about that, remember, in the series and data frame tutorials. So if you are not familiar with those, please go back to those tutorials to understand the structure of the different classes and to be able to navigate through the different attributes and methods. All right. So let's uncomment this and run. As you can see, car ID is integer, car name is object, which also known as string in this case, right? String values are called objects. Door number is also an object, car body is also an object, and so on until the end. All right, let's do the same thing for the other data frame, which is the F engine data, right? So we go here in the same tab, the types, run. As you can see, for example, car ID is also an integer, engine type object, fuel type object, etc., etc. All right, awesome. Next, count non-NA or non-null values for each column in the DF engine data frame. For that, we simply use the count method in the data frame class, right? So let's uncomment this statement and run it. As you can see, we have 207 across the board for all the columns in the data frame, right? Now, if you're unsure about the method or anything, again, you can navigate the documentation, the official one or the non-official one in order to understand the different components. So here we can search the count function. Here you go. And as you can see, the count the non-NA cells for each column or row. Here we can see the parameters and the returned value. All right. Get the number of rows and columns in the basic data frame. Before that, let's do let's get the number of non-null values for the DF basic data as well. So we didn't do them in order, and that's fine. Count. As you can see, similarly, we have 207 non-null values across the board for all the columns. All right, next, get the number of rows and columns in the basic data frame. For that, we can use simply an attribute called shape, which basically returns a tuple containing the number of rows and column. So execute. We have 207 rows and 12 columns. This is basically called the shape of the data frame. Okay. Get the number of rows and columns in the DF engine data frame. All right. And comment, run. Same thing. We have 207 values and 13 columns. All right. Next, get the number of duplicated rows in the DF basic data frame. Okay, now we talked how we can do that. We can use the duplicated method, which returns a series or a data frame of Boolean values, where true indicate that this row is duplicated and false indicate that this row is not duplicated. It's basically the only copy of the row or value, right? Now we can append the sum method in order to uh, count the number of true values or the number of the duplicated values. Okay, so let's uncomment this 9. As you can see, we have 2 duplicated values in the DF basic data. Next, drop the duplicate rows from the original DF basic data frame copy and then confirm that they have been eliminated. All right, for that we can use the drop duplicates method, and we can pass the argument, specifically the keyword argument in place, and we set it to true in order to affect the original copy of the data frame. So here we are manipulating the original version or copy of the data frame. We are not creating another copy of it with the duplicates dropped. No, we are affecting the original. To do that, we pass this argument in place is equal to true, right? Next, let's uncomment this line in order to again sum up the number of duplicates, and we expect it to be 0 in case the drop duplicates method worked as expected. So let's run. As you can see now, the number of duplicates is 0. All right. And remember, in notebooks, only the last statement uh, of printing will be displayed in the results here, not everything before it. All right. Next, get the number of duplicated rows in the DF engine data type data frame. The same previous operation, but on the other data frame. So we apply the sum first. Clearly, we have two duplicates. Again, drop the duplicates from the original copy and then confirm they have been eliminated. We do the same thing here and same thing here. And there you go. Now we have 0 duplicates. Again, if you want to see the duplicated values, then you can investigate both of these data frames or both of the CSV data files on your own just to see where are the duplicated rows. All right. Okay, next, split car name column into make and model. All right, before that, let's take a look at the basic data frame. All right, here you go. As you can see, the car name consists of the make and model. Both of these information are in the same uh, column, right? So, for example, here we have Audi 100 space LS, right? We want Audi to be in a column and 100 LS to be in another column. Alfa Romeo in a column, Giulia in another column as the make, and so on and so forth. All right. So to do the split, we first reference the specific column we want to split. In this case, we reference the whole data frame called df basic data. And between square brackets, we reference the column name. This will return a series object because remember, a data frame consists of multiple series. So this whole thing will return a series. Next, we will use the str method, right? And from str, we will use the split method, okay? And from here, we pass these arguments. N is equal to 1 and expand is equal to true. All right, now let's both understand this method. All right, so we go to series, right? And from series, we go to str, right? And let's go again, str.split. All right, str.split. Here we go. All right, split strings around given separator or delimiter. All right, now split the string in a series, index from beginning and specified delimiter string parameters. Path string or regular expression split on and limit the number of splits in output. 0, -1 will be interpreted as return all splits. Okay, limit number of splits in output. Okay, so how many splits we want to do in this case? Only one one split, right? The make and the model. All right, so n, the value of n will be 1. All right. Next, we go to expand the split strings into separate columns, right? If true, it will return a data frame expanding dimensionality. So if the series contained two information, the make, the model, and the model, expand will basically return a data frame of 2 columns. Each column contain one information, the make, and the other column will contain the other information, which is the model. The returned value will be a series or a data frame, depending on the parameters here, which basically dictate the type of split that will be done. All right. So as you can see, we both understood the behavior of this particular method. right? So series name dot str dot split, and then we pass these arguments. Okay, now let's uncomment this just to see if the uh, columns were splitted. As you can see, splitted column, splitted car name, sorry, is a data frame consisting of two columns, 0 and 1. 0 basically represent the make and 1 represent the model. Now, change the column names in the resulting data frame to make the model make and model instead of 0 and 1. All right, to do that, we reference the columns attribute, right? And then we pass a list of the names of the columns we want. All right. So again, to rename or to reorder the columns in our data frame, we use the columns attribute, and then we pass a list of the column names. So we do that. As you can see, the names of the columns have been renamed. Now confirm that the columns have been renamed. We did that here. All right, great. Now drop the car name column from the original data frame copy. Okay, so we can drop the car name. Why? Because we have the make and model stored in a separate data frame that we are going to use later on. All right. So how we can do that? How we can drop the column by simply using the drop method, right? And then we specify as a string the column we want to drop. Axis 1 basically represent the columns, not the rows. Axis 0 represent the indices or rows. Axis 1 represents the columns. So we specify axis as 1, and then in place equals true to affect the original copy. So we want to drop it from the original DF basic data. Again, to verify the behavior of this function, we search for the drop function. Are we dropping from a series? No, we are dropping it from a data frame. So we go to this part here. As you can see, drop specified labels from rows and columns. Here, access whether to drop labels from the index or the rows or columns, one or columns. All right, in place equal true. If false, return a copy. Otherwise, do operation in place and return none. What does it return? A new data frame with the column dropped. All right. Please always uh, uh, memorize this thought process. Uh, we, I have exhibited here. All right. Uh, Take a look at the documentation, understand the different functions or methods, understand their behavior, and then integrate them into your project. Don't just write code blindly. All right. Be strategic in the way you search for the proper components to integrate to your code or analysis. All right, now let's do the drop, and here we go. All right, let's verify or let's confirm that the change has been made and that the column has been dropped. As you can see, it was the second column and now it has been eliminated. So the operation was successful. Next, print the shape of the DF basic data and the splitted car name data frames. Okay, so we want to retrieve the shapes again after we have applied some operations like eliminating duplicates and dropping certain columns, right? So let's uncomment this statement. As you can see, now we are down to 205 in both data frames, 11 in the basic data frame. It was 12, right? And uh, sorry, we are getting the shape of the DF basic data and the splitted car name data frames, right? So in splitted car name, we are expected to also have 205 rows because we obtained this data frame from DF basic data, right? And now how many columns do we have? Two, the make and model, right? So we are not investigating the DF engine data. We're investigating the splitted column, splitting car name data frame for now, right? Okay, so these are our shapes. All right, next, merge DF basic data and splitted car name data frame. So what we want to do basically is that we want to integrate the new data frame, which consists of the make and model, into the original data frame of DF basic data. after eliminating uh, the car name column. Okay, to do the merge, we call a method called merge, right? Uh, on the data frame we want to merge on. So df basic data dot merge. What data frame we want to merge it with? Splitted car name. All right. Left index is equal to true, right index is equal to true. So in this case, what we are doing is that we are using the index of both data frames as the common column to merge on, right? So it will match the row with index 0 in the left table or in the df basic data table with the row with index 0 in the right hand side table or the splitted car name table. Right, to do that, we specify these two arguments. Again, to better understand the behavior, we go to the merge method. Merge data frame or name series object with a database style join. We will talk about joins in the SQL tutorial later on in this series or upcoming series. But for now, just understand that the merge basically combines two columns together. I will let you read the left index and right index arguments. As you can see, use the index from the right data frame as the join key, right? Use the index from the left data frame as the join key. Setting both of them to true will basically set the join key as the index in both tables. I hope this is clear, right? Uh, Again, test and investigate further on your own, but basically this is the way to do it. All right, next, after doing the split, we want to print out the data frame to confirm that the change has been made. As you can see, we have all the original columns in the original data frame alongside these two columns, which is basically the newly or recently merged data frame called splitted car name. All right. Now, next, print out the df basic data as a Python list, or better, uh, better yet, we want to print out the df basic data columns, right, as a Python list. So, to do that, we call the columns attribute, right, in this data frame, and then we call the toList method to convert it into a Python list. There we go. Now, what would dfbasicdata.columns return? Sorry, let's read this. As you can see, it returned type. It returned an index object, right? So from the index object, if you investigated the index object, you would find a method called toList, which converts this object into a Python list, just like we did. So let's revert back to the original here. Columns to list, and here we go. We have a list of all the column names as a list. All right. Now reorder the columns such that the make and model columns are right after the car ID column. So we don't want them at the end of the data frame. We want them at the beginning, right after the car ID column. To do that, right? Let's highlight all of this. To do that, we call our data frame df basic data, right? We open square brackets. Inside the square brackets, we pass a list of the columns reordered as string values. Again, to do that, we call the original data frame followed by two square brackets, and as an argument or as an input, we pass a complete list of the columns in the order we want. So we change the order such that the make and model are now the second and third columns in this case. Let's run and then confirm that the columns have been reordered. We repeat the same previous operation, .columns.list. As you can see now, make and model are here. Great. Now take a look at the DF engine data frame. Take a look at the DF engine data frame. It's basically, we're looking at the shape of both data frames. All right. As we can see in basic data, we have 205 rows and 13 columns. In engine data, 205 by 13. All right. Okay, so we have similar number of rows and columns. All right, next. Merge the DF basic data and DF engine data frames on a common column, right? So now what we are about to do is to merge both the engine and basic data together. All right. Now, not always the merge or the join must be done on one column that is common between both data frames. This is important. There must be a common column. Remember that, right? This particularly will become clear when we talk about SQL later on. So, to do the join, we call the DF basic data. Again, we call the merge, and then we specify the data frame we want to join it with, and then we list the on argument, right? And we set it equal to a list of the columns or the common columns in both tables. In this case, the common columns or the common column is basically the car ID. All right. Now, can we confirm that? We did before, right? But let's do it again. As you can see, car ID here, engine data, car ID here. All right. We are dealing with the same car data, but the data has been separated into two different tables. Okay. So now we want to merge them together. So on here, if we look at the merge, as you can see, column or index level names to join on. These must be found in both data frames, which is what happened in our case. If on is non-merging index this defaults to the intersection of the columns in both data frames. Extra details that we don't need right now. So on, we specify the common column, which is car ID from the first and car ID from the second. Now, why would we repeat the same information twice? It's because in certain cases, the column name might be different in both tables, but the values are the same. Okay, so the first table, it might be car IDs, and the second, it might be car ID, but both of them contain the same ID values. All right, that's why we pass a list that contains the exact names of the columns we want to join on. All right. Now, this whole statement will return a new data frame, which will be stored in the same or in a new rather data frame called df basic and engine. All right, so let's take a look at this data frame now. As you can see now, it's a data frame consisting of 205 rows, which is expected by 25 columns. So why 25? Why not 26? Given that we have 13 in the first and 13 in the second. That's because we joined on one common column, which is car ID, right? So here we'll have only one car ID column and the rest or the remaining of the columns. 205 by 25. Awesome. Now get descriptive statistic about the merged data frame and store the resulting data frame in a new variable called descriptive statistics. All right. We create a variable called descriptive statistics and then we call our merged data frame and call the method describe. Remember describe? Let's take a look at describe. Here we go. Describe, generate descriptive statistics. Descriptive statistics include those that summarize the central tendency, like the mean, mode, and median. Measures of dispersion, like variance standard deviation, etc., etc. All right. Now let's print out the descriptive statistics. As you can see, it returned a data frame of each column along with the descriptive statistics for each. So for car ID, we can see the count, mean, standard deviation, min, 25th percentile, max, etc., etc. Right? Now, let's investigate the data type just to make sure that it's a data frame. As you can see, panda score frame, it's a data frame. And please be aware of the power of the type function in confirming the data type of the different objects we are dealing with. This will help you better understand the methods and attributes you can use on the resulting value in certain cases. All right.